Good morning, everybody. Today we are going to be continuing to review how to find the volume of composed figures. Today we're going to be working together on pages 699 and 700 in your GoMath book. If you do not have your GoMath book, then you can find these pages attached in this assignment, and you can work off of those. It's also what you're seeing on your screen right now in case you just want to follow along. So let's take a look at one of the first ways that we've learned to find the volume of a composed figure. This is like what we did on Wednesday, where we break our solid figure into two smaller rectangular prisms, find their volumes, and then add them together. The example that we see in our book right here is that our first step is to break apart the solid figure into two rectangular prisms. Now we see that the way that they chose to break theirs up in our notebook is that they went across right here. Remember, this isn't the only way that you could have chosen to break it up. If you had chosen to put your line down here and break it up this way, that would also be fine. There are more than one ways to break up our composed figures. So after we've broken them up, our next step is to find the length, width, and height for each prism. So for the green one, we already have most of our information. We are just missing one thing. We can tell that we have a width of 4 inches, a length of 2 inches, and we are just missing the height. We see over here this height of 6 inches, but that height of 6 inches includes this blue section. When we're looking only at the green rectangular prism, we don't want to include the blue part of its height. If we come over here, we see that the height of that blue part is 2 inches, so we can think 6 minus 2 gives us 4, and we know that the height of our green rectangular prism is 4 inches. The blue rectangular prism, as you can see, we already have all the information we need. Step 3 is to find the volume of each prism. So, if we're looking at the volume of the green rectangular prism, we're going to go length, which is 2, times width, which is 4, times height, which is 4. When we multiply these all together, we get 32 inches. Next, we have to find the volume of the blue rectangular prism. We still use our volume formula, length times width times height. The length is 10, the width is 4, and the height is 2. When we multiply these three numbers together, we get 80 inches cubed. Our final step is to add the volumes of these rectangular prisms together. So 32 plus 80, and when we add these together, we get 112. So the volume of this composite figure is 112 cubic inches. This is the way that we went over solving these problems on Wednesday. Today you're going to see a second option to solve for volumes of composed figures. You can use whichever one works better for you. I personally think that this first way of breaking them up is a little bit easier, but I'm going to show you the second way as well. So if you're working in your notebooks, just turn the page so that you're on page 700. The other way that we can solve for composite figures is by using subtraction. So now instead of breaking up our composite figure into two separate, smaller rectangular prisms, we're going to find the volume of an imaginary whole, one prism, and then subtract the imaginary part that's missing. So you can see in the illustration in your math book exactly what this would look like. So our step 1 is to find the greatest possible volume. If you look in your math book right here, they have kindly drawn in this imaginary rectangular prism so that you can picture what it looks like if the whole thing was filled in. So we're going to find the greatest possible volume of this entire prism right here. Remember, we do this the same way we always have. We use length times width times height. So the length would be right here, 10 inches. The width would be right here, 4 inches. And the height would be right here, 6 inches. Same formula that we've been using, length times width times height gives us our volume. When we multiply these three numbers together, we get 240 cubic inches. Now that's our first step. The next step, if we're using subtraction, is to find the volume of the prism in the empty space. If we're finding the volume of the prism in the empty space, that means that we're finding the volume of this prism that is dotted. This is the imaginary prism that we're going to find the volume of right now. So our first step is to figure out the length, the width, and the height. The length of this is right here. They gave it to you. They helped you out here and told you that it was 8 inches. This is something that you would probably have to figure out on your own, because if you look right up here again, you see that that wasn't information that they initially gave you. So you would have had to use this 10 inches and subtract 2 inches to figure out that this space right here is equal to 8 inches. Okay, that's your length. Next, you would have to find your width. Your width is right here. We already knew this information. This is 4 inches. And you would need to find your height. This is your height right here. Once again, this is something that you would have needed to figure out on your own because they don't automatically give it to you. You would have to look at your original. You know that the height of the total rectangular prism is 6 inches, but we're not doing the whole thing. We're just doing the imaginary part. So we'd need to subtract this 2 inches. 6 minus 2 equals 4. Now we'd find the volume of this purple dotted line, however you want to describe it, this imaginary rectangular prism by multiplying those three numbers, and we would get 128 cubic inches. So this invisible prism is 128 cubic inches. Finally, our last step when we are solving using subtraction is to subtract the volume of the empty space from the greatest possible volume. Our greatest possible volume is right here. It's 240. And our empty space, the volume of our empty space is found right here. It's 128. So we have 240 minus 128. When we solve this, we get 112. So the volume of the composite figure is 112 cubic inches. Now this is a little different than what we had learned on Wednesday. That's okay. You can choose to use this way. You can choose to use the addition like we learned on Wednesday. It is completely your choice. I personally think that we've spent more time on the addition, so it probably makes sense for you to do it that way. But if this way just makes way more sense to you in your head, use this. All right, before I let you go, let's try this one together. Sometimes we end up with a bit of a challenge. Composite shapes can't always be broken up into only two rectangular prisms. Sometimes we have to break them up into 3. The steps are not going to change. We are still going to break these up into 3 rectangular prisms. They've already done this for you. So I'm going to label them. Here's rectangular prism A, B, and C. I'm going to label here just so that we don't get confused. A, B, and C. Next, we need to make sure that we know the length, the width, and the height of each one of these prisms, so that we have the information that we need. If I'm looking at prism A, I can tell that my length is right here. This is good. We have it. It is 3 feet. The width is right here. That's a piece of information that I don't have written right there. So I'm going to have to use what I know about congruent edges within rectangular prisms. I do see that there is 5 feet right here, and I know that those 2 edges would be congruent in length. So the length of prism A is 5 feet, and we need the height. The height is written right here. The height is 4 feet. So I know that my volume, if I multiply those together, is 60 cubic feet. Great, so I found my volume of rectangular prism A. Next, let's find the volume of rectangular prism B. We're going to start with the length. The length is right here, and we already have that information. We know that that is 5 feet. We have the width. This is using these same congruent lines. We know that the width is 5 feet. That does not change. Next, we have the height. The height is right here. It's the tallest point in this composite shape. Even though it doesn't say it right next to it, we do have this very handy number over here showing us that the tallest point of this figure is 8 feet. So for rectangular prism B, we would multiply 5 times 5 times 8, and we would get 200 cubic feet. Finally, we need to find the volume of rectangular prism C. The length of rectangular prism C is right here. This is a piece of information that we don't know and that we can't use congruent sides to help us figure out. What we do know is that the whole length of our shape is 12 feet. We know that it's broken up into 3 different rectangular pyramids. We know that the length of rectangular prism A is 3, and the length of rectangular prism B is 5. So we just need to find the length of C. So this is using just a regular old addition model. 3 plus 5 plus what? Whoops. Equals 12. 3 plus 5 is 8. 8 plus 4 equals 12. So our length is 4 feet. Next, we need to find the width. The width, once again, is right here. It has not changed. It is 5 feet. And the height. The height is right here. They gave you that number. It's 2 feet. So to find the volume of rectangular prism C, we would multiply 4 times 5 times 2, and we would get 40. Our final step right now is to add these volumes together. So we would add 60 plus 200 plus 40. And when we add all of these together, we get that this shape has a total volume of 300 cubic feet. So this is just a bit of a review of what we did on Wednesday. It also introduces you to one other way to solve, to find the volume of composed figures. Next, we're going to do some problems on your own. I hope this helped. Have a great day.